Hi everyone, this is the IB Probability and Set Theory package. We're now looking at the section on dependence, and this is example 1 here, classifying events as independent or dependent. This idea of independence and dependence is in some ways a little bit misleading. What we're looking at are two different events that occur at the same time, or they occur one after another, or whatever. There are two events occurring. When we talk about mutually exclusive and non-mutually exclusive, it's basically just one event that could happen in one way or another. But in this case, we are looking at two specific events here. Now, there is a formula for independence and dependence in terms of their probabilities, and that is sometimes the best way to look at it. Unfortunately, the words independent and dependent tend to indicate a link between the events, which in many cases is true, but not always true. But for the most part, as we go through this section, that will be what's necessary to understand what's going on here. Essentially, for a lot of the questions we're going to look at here, if the first event changes the sample space for the second, then they're dependent. Okay? So let's just take a quick look here. All we got to do is classify these things. And so you've got the sheet here. The trial is flipping a coin and drawing a card from a deck of cards. The first event is rolling a heads, and the second is drawing an ace. Okay, well, does the one affect the sample space for the other? And the answer is no. So these are definitely, independent events. Independent events. Okay. Now let's look at the next one. The trial is rolling a red and a green die. The first event is rolling an even number on the red die, and the second event is rolling a 6 on the green die. Now, again, that first event, because we're talking about two different die here, or two different dice here, I should say, they're independent of each other. The one does not affect the sample space for the other. Away we go. The next one. The trial is to sample two members of a family, a mother and her child. The first event is that the mother has brown eyes, and the second event is that the child has brown eyes. Okay. Now, is there a link between those? Yeah, absolutely. There's a genetic link there. We would expect those to be dependent, particularly if the mother has brown eyes, that would have an impact on the child. So those would be dependent events. The trial, D here, the trial is drawing two marbles from a bag containing 3 red, 5 white, and 2 blue marbles, replacing the first marble before the second is drawn. Okay, now that's an important word there. Replacing. Okay, so we're going to talk that through in just a second here. So now the question is, okay, the events are, the first event is that the first marble is red, and the second event is that the second marble is white. Now, does the first event affect the sample space for the second event? And in this case, the answer is no, because when you took that first marble, you put it back. So we go right back to the initial situation. These are independent. That first event does not change the sample space for the second event. E. The trial is drawing 2 marbles from a bag containing 3 red, 5 white, 2 blue. Okay, so it's the same question. In this case here it is, without replacing the first marble. So the first event is that the first marble is red, and the second event is that the second marble is white. Now, does the first event affect the sample space for the second? Yes, totally. We got one less marble there to choose from, so those are dependent events. Now, when you're working through this, just a quick word of advice here. One of the things that caused me a lot of problems when I was learning about probability is I always was confused by what happens with that first event. Because, well, what if I didn't draw that red marble? And how would that affect the probabilities? But when we're talking about probabilities and we're calculating these things, you always assume success. When I was in high school in your position, I didn't know that was the rule here. But the rule is we always assume that first event succeeded. Okay, and then we talk about how it affects the second one.